lot of what you're going to see in section 2.7 is going to be just working with function notations, a little bit more practice with domain, and it's going to start with function notation. So we've got two functions here we're going to work with. G of x is this one. And let's do f of x in a slightly different color. So f of x is this one. And you can bet that the numbers here are nice integers, at least as far as we're going to need them. One thing to be careful of is that this is the y-axis. And they're going to ask you, for instance, for f plus g of -1. Well, that's just notation, and it kind of looks like you can distribute. In fact, it's really what the notation is leading you towards. That's f of -1 plus g of -1. I expect that you can find these values from the graph. So it's a matter of just looking at the graph at x equal -1. That's right here, just to the left of your y-axis. And then first of all, finding the y-coordinate for f. So f of -1 is going to equal what?
1.
Yeah, it's going to equal 1. Alex, how about g of -1? What's g of -1 going to equal? 1, 2, 3, 4. Yeah, g of -1 is 4, so 1 plus 4 is 5. Thank you. Likewise, some more of this kind of notation. This is going to be f of -1 minus g of -1. Fortunately, we don't need to get new values for this. This is, again, just notation. So it's going to be 1 minus 4, which would be -3. What do you think's meant by this one down here? What do we got to do with that one? Yeah, just multiply them. F of -1 times g of -1, which again is going to be the 1 and the 4. This time they're multiplying each other. What about the last one? What's going on with that one? Yeah, you're dividing. So f of -1 divided by g of -1 is going to be 1 over 4. Nothing too dramatic there, just some notation. And again, I expect that you can get these kind of numbers from your graph. So hopefully nothing really dramatic there. We are going to look at some more with example B. I think I'm going to take and write this on a separate sheet here for myself, just to give myself a little bit more room with that. Not that we really need it. Yeah, question?
The second sheets with the class notes.
What's that?
Like if you write something else on another sheet, do you upload that?
Oh
with
yeah,
the class notes?
yeah. It's all going to be part of the class notes. So when I'm really on my game, I number these pages so that way they all go in order and stuff like that. So yes, I will be putting them there. So let's take a look at this next page then. So this is example B. We've got f of x equals 3 minus x squared, and g of x is x squared minus 4. And again, it's the same thing being asked here that was asked just a moment ago. It says this time we don't have actual numbers that we're going to calculate. It's just combining these functions together. So one of the first things they ask you for is f plus g of x. And that really means f of x plus g of x. Now we don't have numbers to give this to get this time. That's okay. I'll replace this with 3x minus x squared. I'll just put that in parentheses just because. And then over here, x squared minus 4. Can anyone simplify that for me? Close. -1. Yeah, -1. -1. That's it. So when you add those two functions together, things cancel out and you get -1. Graphically speaking, if you were to look at that, then here's your graph of f of x. It's a parabola that faces down. Here's your graph of g of x, faces up. But when you look at 2 points that are opposite, let's look at, for instance, f of 0 and g of 0. when you add those two together, 3 plus -4, well, you get -1. If you find two other points, let's say over here at -3 you get +5, and at -3 here you get -6. -6 plus +5 gives you -1. No matter what you add, when you add these two functions together, you get -1 when you add them. So, all right, nice. Actually, let's just shut those off and work with example C. Now, for example C, actually no, I'm getting ahead of myself. Let's do a couple more here for f minus g of x. That's going to be 3x squared minus x squared minus 4. This time things aren't going to disappear quite like they did with the last one. Yeah, somebody mentioned the right word there. Who was it out there? Distribute. Yeah. So it's going to be 3 minus x squared minus 4. And the thing you should notice is that both of these x squared terms have a negative there. Negative and negative give you, well, another, negative 2x squared. 3 minus 4 is -1. So,
Maybe +4 because we're subtracting 4.
you're right. So it should be +4. Thank you. Oh, that's so embarrassing. +4, and 3 plus 4 would be a +7. So there we go. No harm, no foul. Don't worry though. If you make a mistake like that on an exam, I'll just simply mark it wrong. Okay. All right. Let's try a couple more. Let's do f times g of x. So it's going to be 3 minus x squared times x squared minus 4. What do you suppose I got to do with this one? What's the word that you think of when you multiply binomials together? Yeah, distribute or FOIL. I mean, most people remember with the acronym FOIL. So you're going to get 3x squared minus 12 minus x to the 4th, and then plus 4x squared. I do want to clean this one up a little bit, especially because there's like terms. I do suggest that you write this in descending order. That is, the largest monomial term first. That's a minus x to the 4th. And then in the middle, 7x squared plus 12. Nice.
Minus 12.
Is that minus 12? Yeah, minus 12. I did it again. Man, I'm glad I'm not testing myself today. All right, minus 12. Nice. Okay. The last one that we can look at would be f divided by g of x. So f divided by g of x is simply going to be f of x over g of x. Thank you. 3x squared divided by x squared minus 4. And it asks us for a little bit more from this one. It asks us to find the domain. So, Geo, what am I have to do to find the domain? That's not my big problem on this one. Alex?
Multiply numerator and denominator by the conjugate of the denominator.
Maybe if we're dividing fractions. Alex? Oh, I'm sorry, Nick. Yeah.
You said behind 0.
Yeah, the problem with this is we can't let this equal 0 in the denominator, right? It's not well defined when you divide by 0, so we're going to have to figure out where this is equal to 0. Antonio?
Would it be x squared plus 4?
So for the domain, x squared minus 4, we want to find out where this is equal to 0. So x squared equals 4. I hope you don't just give me x equals 2. Remember, when you take the square root of this, there's really a plus or minus square root. So both of those values are places you want to avoid. So if you're looking at it on a number line, it'd be negative 2 and 2. These are the places we want to avoid. Everything else in between is okay. So what would that look like in interval notation?
X does not equal positive or negative 2.
All right, but that's not quite interval notation. Left-hand endpoint and right-hand endpoint. What would that be? So
From
start out this interval.
Infinity to -2.
Negative infinity, negative 2. Good.
Both in parentheses.
Mm-hmm. Keep going.
2 parentheses to positive infinity.
Negative 2 to 2.
Oh yeah,
And 2 to infinity.
infinity.
There's a lot of you, well, not a lot, but I mean some of you on the exam lost a point because you forgot this middle interval. You gave me these two, but you forgot that middle one for some reason. I don't know. It's all right. I only took off a point, but you need all three of them. That would be your domain. Your domain is everything except those 2 points. And if you're stuck writing it in interval notation, that would be this. If I don't say anything, you could get away with x is not equal to plus or minus 2. I don't care. But if it asks for interval notation, then this is what I'm looking for. Nice. All right. So let's move on to example C. So I've got these two functions. And I want to look at a couple different things here. I want to look at f plus g or f minus g, f times g, f divided by g. I'm actually only going to focus on one of these. Let's look at f plus g. I hope that you're comfortable enough with the notation that you can find those for yourself as needed. But let's start with the easier of these two. In the last problem, when we were talking about the domain of our function, we had to avoid where the denominator was 0. That's what we avoided. What do we have to avoid here? What are we worried about with our radical functions?
Negative.
Yeah, imaginary numbers, and that's going to occur when what happens underneath the radical? What's going on there if this is going to be...
A negative number.
Yeah, it's going to be a negative number. So we want this to be positive. So rather than find what we can't have and throw it out, let's just find what we can have. We want x plus 3 to be greater than or equal to 0. Okay. So that's going to mean x is greater than or equal to what? Negative 3. So that's our domain of G. Okay. For the domain of f, I want you to get the domain of f by actually looking at the graph. So let me pull up the graph of G. There's the graph of G of x. What's that look like? What's the domain of G of x?
G of x be the other side.
It's got a different notation here, but it's the right function. 16 minus x squared. I can only use G of x, I can only have it defined once, so that's why it's got a r of x here. But it's really our function G of x. 16 minus x squared. Michael, I think you had the domain there. What's the domain on that one?
Negative 4 through 4.
All right, good. The domain here is negative 4 to 4.
Actually write it out. So it's writing out that.
Well, we got that one visually. Getting it actually algebraically is a lot of work. And it's not something I want to spend my time on, but I'll remind you how you would do that. And that is, and I'll do it kind of really quickly here. So what you're looking for is where 16 minus x squared is greater than or equal to 0. And then you do 4 minus x and 4 plus x greater than or equal to 0. And you realize that that could equal 0 at x equal 4 and negative 4, and then you run through and you test points like that. And let's see, actually the other way around. I think it would test out negative, positive, negative. And then the middle interval is what you would want. You're welcome. All right, so let's take a look at the function f plus g. F plus g of x is simply going to mean the square root of 16 minus x squared plus the square root of x plus 3. But that's only going to be defined where the domains overlap. So let's figure out where the domains overlap. We've got two domains here to work with. We've got this one here, x is greater than or equal to negative 3. And I've got this one here, x is between negative 4 and 4. So what's that look like when I find where they overlap? Let's do that up here. Now on my graphs I typically put just the points I need. So just the points I need would include a negative 4 and a 4, and then also a negative 3. Let's graph the first part of this, negative 4 to 4, and I'm going to put that underneath here. Solid dots on both ends. How about the graph of x is greater than or equal to negative 3? Solid dot or hollow dot?
Solid.
Solid
Gonna go to the right.
to the right. Now give yourself a second, but look at this and see, where do these overlap? Where do the domains of these functions overlap? So where are they both going to be defined?
Negative 3 and 4.
Negative 3 to 4. Question?
No, negative 3.
Negative 3 to 4. Negative 3 to 4. All right. Yeah, so right here. This is where they overlap. So that's your domain right there. That's where they overlap. So the domain of this function is exactly that, negative 3 to 4. Now the cool thing is that Desmos understands this and can show that to you visually. So let's take a quick look at that visually. Here's your graph of g of x. So it's top half of a circle. All right. Here's the, well, actually the first graph was f of x. Second one is our g of x. The third one is going to be where they overlap. Oh. And what you see is that you're just getting a function defined at negative 3 to positive 4. That's it. That's all this function exists for, because that's the only places where these two domains overlap. So kind of neat the way that works out. Now, I could also look at the domain of this function. The quotient of those two, so f divided by g. And you might think that it's going to have the same domain as this one, right? Should be the same domain like this. But it's not quite. You have a point here, but do you think negative 3 is part of the domain for this second function? No. The problem is, if you put in a negative 3 into this term in the denominator, what's negative 3 going to do to this term? Negative 3 plus 3 and then take the square root? Yeah, you're going to get 0. So the function is not going to be defined at that point. So, bummer. So your domain for that one would be negative 3 to 4, but with a parenthesis on the negative 3. So, a little subtle difference in that domain. I'm going to give you a chance towards the end to work on this one, so keep in mind what we just did. Let's take a look at example E. So So it says decide which graphs represents f plus g. Well, here's your graph of f. So graph of f is the same in all these. Graph of g. Oh, actually, you know what? F plus g is... Alright, this is f plus g, f plus g, f plus g. Sorry, I'm doing f plus g, not f. There. And here. So if you're asked to figure out, well, which one's f plus g, the best thing I would suggest is you actually start finding some points and just looking at what happens. For instance, let's take a look at these 2 points. So I want to look at, let's see, 1, 2, 3, 4, 5, 6. I want to look at f of 6, f of 6 plus g of 6. What's the value of f of 6? Simon? What would f of 6 equal, please? So let's see, 2, 4, 6. What's the y coordinate here when I go to the graph of f? Negative 2. So negative 2. How about the x coordinate? Elise? What would the, excuse me, not the x coordinate, g of x. What's g of 6 going to equal? Yeah, positive 2. So you go out to x equals 6, you go up here, positive 2. So if I'm looking at these graphs and I wanted to figure out, well, which one of them is right, f plus g of 6, f plus g of 6 should equal what? Equals 0. What does f plus g of 6 equal here? Whatever it is, it's not 0, right? F plus g of 6 here looks like it's more like, what, 4, 5? Let's see, 1, 2, 3, 4, 5. Looks like 5. So that one's not the right one. Is there a graph in here where f plus g of 6 is 0? Yeah, the last one right here, right? F plus g of 6 equals 0. And that's the only one with a 0 at that point, so that's the only one that we have to look at. That's the only one that it could be. Now, you could double check it some other way. In fact, you could check it with, say, these 2 points. So let's look at 0. So f plus g of 0. F plus g of 0 looks like that. But we could also calculate it as f of 0 plus g of 0. So let's kind of zoom in a little bit. Maybe make it a little easier to see. And try and calculate for yourself. What's f of 0? Let's highlight that a little bit. So there's our f of our function of f. Here's our function for, I don't want that one, I want this one. Here's our function for g. There we go. Zach, what are we getting for f of 0, please?
So f of 0 would be 1.
Good. Pfeiffer, g of 0?
No, 2, sorry.
2, yeah. And 1 plus 2 is 3, which is your g of 0. So if you weren't sure at first, then you can be sure now that f plus g of 0 matches f of 0 plus g of 0. In other words, this is the right graph. let's flip to the back side, or the next page, I should say. So we've got two functions, f of x and g of x. F of x is this one, out that way, and g of x is this one. So let's take a look at these combined functions. Let's start by figuring out their domains. So you can do that a couple ways. You can look at the graph, figure out the domain of each of these, or you could just figure it out this way. So the domain is going to be where 1 plus x is greater than or equal to 0, or in other words, x is greater than or equal to negative 1. Okay, so that's right here, negative 1 to infinity.
By definition, would these all be inclusive or not?
You're going to include the left-hand endpoint here because you can take the square root of 0. So yeah, you can use the negative 1. How about up here? What's the domain of that one going to be? Can you do that one? Go ahead, Antonio. X less than or equal to 1. Yeah, so kind of the opposite direction here. So we're going to start out at, you know what? I should have drawn this in green if I want to keep things consistent. There we go. So over here, I want x is less than or equal to negative 1. Where are those overlapping? Negative 1 to 1. So they're overlapping right in here. And that's exactly what we're seeing from our graph. Now that graph's going to include the endpoints, so it's going to be defined here and defined here. So does that mean bracket or parentheses for the domain?
Brackets.
Brackets. Nice. There's a different version of those kind of problems that I can ask, but I got to talk about a little bit more notation here first. Let's move down to G. This is called iteration. When you do a function and then you use that value to plug into the next function, it's called function iteration. So let me start by finding, for instance, the inside part of this, f of 2. So let's look at our function and just do the inside part. The f of 2. Put that in here. F of 2. F of 2 is going to be 4 times 2 minus 3. What does f of 2 give me? Yeah, 5, right? F of 2 is going to equal 5. So I'm going to put the 5 in here. And now I need to find f of 5. So let's find f of 5. So f of 5 is going to be going back to the same function. It's going to be 4 times this number, 4 times 5 minus 3. This time f of 5 gives me what? 17. 5 is 17. And that's it. why would you do function iteration? Well, you could have, you know, forecast of 3% inflation or 2% inflation, so you plug it in and you calculate inflation prices for next year, and then you want to do it again for the year after that. So you take your value from next year and you put it back in to your original function, you keep on going. So you can do things again and again like this. Why don't you try g of 3? So same kind of thing, it's just this time you're working with a different function. G of x is 5 minus x squared. So we'll start out inside like we did just a moment ago. So start out with g of 3. Antonio?
Do you want me to give you?
All right, sure. We'll start out. Work me through it. So g of 3. What does g of 3 give me?
5 minus 3 squared, and then equals -4.
Good. And what about g of -4? What's that going to give me?
Would you make it a +4 first, or would you square
Well, you can square -4. -4 times -4 is what?
that would be 16.
And 5 minus 16 gives you -11. Perfect. So -11. Yay. So just a matter of going back to the same function a couple times to put that in and get your values. All right. Cool. Well, I think we have enough time for example J and K here. So, but let me go through examples H and I. Again, I want you to be able to read things off of a graph and answer problems on a graph. I'm hoping that these are user-friendly problems. I don't put them on exams to be difficult. It's just a matter of, do you understand some of this notation? Can you follow along with this and find these values? So it's not meant to be difficult or challenging. Let's work with f of g of 4. So here's my graph for g of x, and I think it actually comes down a little bit farther than I've drawn it. Kind of drawn over. Does it end right here? Can you see it on your unmarked graph?
Yeah, and then
So let's put a little point like right here. Right there is where it ends. Meredith, maybe you can help me out here. What's g of 4 look like? What would the value of g of 4 be?
3.
Yeah, it looks like about 3. 1, 2, 3. Perfect. So that's going to be g of 4 is 3. So you're going to replace that 4 by a 3 here, or g of 4 by 3. Thank you. Now we need to look at f. And Helene, maybe you can help me out with this one. F of 3. What would f of 3 equal? Helene? F of 3? So what you want to do when you're finding these values is you want to move over on the x-axis until you find your value of x. So that's 1, 2, and 3. And then you want to go until you find your graph, and you want to look at the y-coordinate. So if I was looking at g of 3, 1, 2, and 3, g of 3 would be 1, 2, 3, 4, 4.5-ish, 4.6, 7. But what about f of 3? What's f of 3 going to be? Anyone? Elise? F of 3? It's alright, no worries. Josh, f of 3?
That would be 0.
Yeah, 0. You're right on the x-axis there. All right, ladies, are you okay with where these are coming from for like the g of 4?
Could you explain the G of 4 again? One more time?
All right, so let me take a look at my handout this way, because I think it might show up a little bit better. So right here, this point where my cursor is, let me see, can I make this bigger? View. There you go. So right here where my cursor is, if you go over to 4 on the x-axis, which is right here, and then you go up to your graph, right there at the end of this tip is the value of g of 4. And that's at a height of 3. So g of 4 is 3. And then when you look at g of 4 being 3, now you want to find f of 3. And f of 3 is just your y-coordinate on for the value of x equal 3. And that's back here. And that just happens to be right on the x-axis. So your y-coordinate is 0. All right, thank you. These are good. I like these because, again, there's not much calculation. It's just a matter of, do you understand some of this notation? So let's do 2 of these, and then we'll finish up with examples J and K. So, okay, f of g of 3. Instead of having a function, though, you have a table. When you do these kinds of things, you need to work from the inside out, f of g of 3. So let's work with the inside part, g of 3. How are you going to find g of 3? Well, first find 3 on the row for x's, and then go to the table to find the value for g of 3. So in this case, g of 3 is equal to, anyone? 4. G of 3 is equal to 4. Now I want to find f of 4. So do the same thing. You find the value for x equal 4, and then move down to the table to find f. And you get a 1. Your turn for 1. This time let's look at g of f of 3. Do you think it matters if I switch the order on g and f? I mean, you can say the same thing, right? You know, g of f of 3 and f of g of 3. All right, well, let's find out. Find out by testing it. Start with the inside. Find your f of 3, whatever that gives you. Plug it into g and find g of that. See if you get the same thing either way. All right. Gia. Start out with f of 3. What's f of 3 going to give me, please? 5. So that's going to be g of 5. Simon, when I get g of 5, what's that going to give me? 6. Nice. Thank you both. G of 5 is 6. All right. There's one last type of problem that you're going to get, and it's down here with these last two. They might seem like kind of like, oh my God, why are we doing this? What are you going to do with something like this? And let me give you an example first. What are a couple different temperature scales that you've heard of?
Fahrenheit.
Fahrenheit, another one. Celsius, another one.
I was gonna say that.
Kelvin.
Kelvin. All right, Fahrenheit, Celsius, and Kelvin. So, if you're starting out with degrees, let's see, Celsius, and you want to convert to Fahrenheit, the function looks like this. That's going to take Celsius and convert it to Fahrenheit. You could also start out with degrees Kelvin and convert degrees Kelvin to degrees centigrade or Celsius if you take and subtract like 273.15 or something like that. So if you wanted to come up with a, you started out with degrees Kelvin and you wanted to convert to degrees Fahrenheit for some reason, then it looks like you got to do 2 iterations of this function. Well, really, what you could do is you could combine these two. You could take this and plug it in for x. So you get f of all this, x minus 273.15. Plug that in for f, 9/5 times all that, plus 32. And this function is going to be kind of nice because now you can go directly from degrees Kelvin to degrees Fahrenheit. So you don't have to do 2 kind of steps here. You can do it all in one. And you can clean this up. That's not really the point of this exercise. But a lot of times you are going to combine functions. And when you do have a combined function, then some of your rules for calculus change. You're going to have to use what's called the chain rule. So it's nice to be able to recognize that this is the combination of 2 functions. The 2 functions that I see here, let me just call this h of x for convenience. 2 functions I see here, one of them is a reciprocal function, and the other one is just the denominator of this, x plus 1. If you put these 2 functions together in the right order, then you're going to get this function. So you're going to have what I call the outer function and the inner function. The outer function is kind of the big picture. I'm seeing that you're taking the reciprocal of something. So that's going to be the outer function. And this is going to be the inner function. And if I put those two together, if I do f of g of x, that's going to give me this function. It's going to give me my h of x. So that's a function composition. And it's looking at this and realizing that it's really 2 functions put together. Michael, you had a question on that?
In short, an example like this is asking us to decompile something
Yeah.
to multiple simpler functions.
Yes, that's exactly right. You're deconstructing this into 2 simpler parts. F of x is 1 over x. G of x is x plus 1.
Yes. But what did you write as the final answer?
Oh,
H.
f of g of x is h of
I
x.
couldn't read it. It looked like
I'm sorry,
Thank you.
Rachel. This is an h. There we go. All right, so we're clear on that one. Now, if you put these in the other order, then it's wrong. If you did g of x, or g of f of x, that's not going to give you this anymore. It's going to give you something different. Let's turn our attention to this last one and see if we can figure out well, what's the f of x and what's the g of x? Now, big picture, when you first look at this function, what's happening? You've got the absolute value of something here, right? So let me zoom in a little bit. That's the first thing you see when you're looking at this. So that's what I call your outside function. So your outside function is f of x is just the absolute value of x. What's that leave for your inside function then?
1 minus x4.
Yeah. G of x is 1 minus x to the fourth. And then if you put them in this order, f of g of x equals your h of x. And let me put a little star up here, and then a star here. Let's see. Oops, other way. There you go. So, Rachel, that's for you. A little star. All right. All right. This is not a hard problem, but it's worth a little bit of attention to when you get to your homework, because when you get to calculus, you're going to have to recognize that you get an outside function and an inside function. That's really a composition of functions. So, yeah, it may not be the funnest problem that you're going to see on an exam, but hopefully it's not the hardest as well. All right, all set. Have a good one, and see ya.